Hi, I'm Tony Alicea, and in this video, we're going to take a dive under the hood of the new Resumable JavaScript framework called Qwik. What are Qwik's innovations, and how does it accomplish them? We'll take a look at a couple of examples, we'll dig a little bit into its source code, and we'll do our best to truly understand. At the time of this video, Qwik was just released into beta, and you can find it at qwik.builder.io. And I'm here in the playground, where we can try Qwik out. I've written a basic component that just has a button that, when clicked, will alert my first name, and I've stored my first name here in a variable. With Qwik syntax, I'm wrapping a function in a call to component $. And this causes this function to be a Qwik component. The actual HTML delivered to the browser is being rendered on the server, and I end up seeing the app here. Now watch what happens down in this console when I click the button. The alert occurred, "Hi Tony," and down in the console we see that two JavaScript files were loaded, this long name and app2.js. So why were these files downloaded, and what are they doing? Well, first let's go to the HTML. What's happening when I click this button? If I scroll down, I'm going to see a lot of Q colons. Qwik is already putting extra information into the HTML. That is, it's serializing information into the HTML so that it can make decisions later. Here, for example, my onClick $ is converted into on:click. And inside of that is this long JavaScript file name, followed by a £, followed by another name. And this is one of the first things to note about Qwik. The code that I'm writing is not the code being delivered to the browser. Qwik is automatically splitting my code up, and we can see that here inside client bundles in the playground. When I go to app2, that actually looks just to be Qwik's source code. But if I go down to these other files, I can see my component. See, there's my first name. The JSX was transformed. JSX, of course, much like it is in React and other frameworks, is being converted into JavaScript code to create a tree of objects. And we see the onClick $, rather than directly being the function, is now wrapped in its own function called QRL, which then does a dynamic import of this JavaScript file with the long name. And it passes another long name. I can find this JavaScript file here, the last file in the client bundles, and it's the code that was inside my onClick. But there's an extra line of code here using something called useLexicalScope to get access to the first name. And then this function is exported at the end of this file. So that's a lot going on. And there's even more. If I go back to the HTML delivered by the server and I scroll down a ways, I can also find this JSON block of information. And there's Tony, which was the value I put in the first name. And there's another script with an ID of Qwikloader, which looks to be a bunch of code, although actually not that much. Finally, there's another script which is pushing a string value into something called Qwik events, which is global. So why is all of this here? What's it doing, and what's it allowing Qwik to accomplish? Well, we're going to take a look at two particular features of Qwik that encompass what you're seeing: the optimizer and the Qwikloader. First, let's look at the optimizer. I'm going to go into Qwik source code. I'll click here to the link for the source code in GitHub, where I can grab it, and I'll download it all into my machine and open it in Visual Studio Code. And here it is. Under Packages, I'll go to the Qwik folder, Source, and then I'll find a folder called the Optimizer, and under that, the Core, and there's the source. And I have a bunch of files, but they're not JS files. They're .rs files. This code is written in the Rust programming language. What is it doing? Well, right away, I notice a file called parse. And as soon as I see a file called parse, I start to think that this is looking at text and changing text in some way. And that's exactly what's happening with the Qwik optimizer. The Qwik optimizer is, in a way, a compiler. It's taking the code that I wrote, those JS files, examining it, and creating new files based on my code that's actually delivered to the browser's JavaScript engine for execution. And within this optimizer, it has certain phrases that are important to Qwik. For example, component $, or just the $sign in general. What here is referred to as a Q hook. That means that every time I see the $sign, the optimizer, when analyzing this text of this file, is treating it differently. It's saying, here's a point where essentially I should split the code. When I see on-click $sign, that means I'm going to have some code, typically a function, that should be pulled into its own file. And that's what the optimizer is going to do. The optimizer is essentially saying, prepare for this function to be lazy loaded. By lazy loading, meaning it's going to be downloaded and executed separately when it's actually needed. So you can think of $sign as, please lazy load this. Don't bother asking the JavaScript engine to parse and deal with it until you need it. In other words, a proper mental model of the optimizer in Qwik is that of a text processor. We give the optimizer some code that we've written, and when it finds the $sign, it takes the body of our code and creates a new file. And then where our code was left, it replaces it with a reference to that new file, and also with a reference to what Qwik refers to as symbols. And we can think of that as merely the variables that are exported from that new file. Where can I go find this function that should be executed? If you imagine this being done across your entire application, then you end up with a lot of small files, what Qwik refers to as chunks, which over time may or may not be executed by the browser. The call to execute those functions is wrapped in something called a QRL, which seems obviously inspired by the idea of a URL or an address. So what's happening inside that QRL function coming from Qwik? Well, let's go back to the HTML delivered when the page is actually sent to the browser. There's a script called the Qwikloader, and that's the other piece of the puzzle we'll look at. After we have all of these separate files that are ready to be lazy loaded, we need to be able to actually respond to the events, the clicks and things that the user does, and then lazy load those files. That's what the Qwikloader is. And that's basically the JavaScript that you're actually going to load the first time you load a Qwik application, and pretty much nothing else. Now, this version of Qwikloader is minified and a bit hard to read, so let's take a look at it at the source code level, which I can find under Qwik, src, and qwikloader.ts. Now, note that at the time of the recording of this video, Qwik is in beta. The structure of this code will change, things in the code will change, but we're not trying to understand the structure of Qwik source code. We're trying to understand how it's trying to do what it does. So what is the Qwikloader doing? And how does a QRL work? Well, if I scroll down a bit, I'll find the QRL resolver. So when I give it a QRL string, it's actually going to convert that into a URL, the actual address we should go and get the file at. So that makes sense. But how does the event tie to going and getting the file and executing it? Well, if we scroll down, we see a dispatch, which generally means an event has happened. We can actually see that we're looking for an attribute name that starts with on, and then a colon, and then the event name. Remember, we saw on:click. If I scroll down further, I can see that when we look at the value of the event, remember on:click was pointing at a JavaScript file name, one of those JavaScript files created by the optimizer. It resolves that QRL, it figures out the exact address that it should get, and then at some point, it's actually going to read it in. Remember, there was a £, so it's ignoring the text after the £, which was the symbol name, and is just importing based on that URL. So Qwik, when we go back and look at the onClick, it's going to handle this event and then import this JS file when that event happens. After that, it's going to have a module with the symbol name portion of that URL. Remember, after the JS file, there's a # and then a symbol name. So it's going to find that from the exported module. We can see that in the client bundles, that at the end, there's the exported name. And that is the same name here after the #. At that point, it now has the function, which it calls handler. And eventually, it executes the handler. So it's grabbing the code and executing it. And that's how my onClick event function was run. But how do these events get tagged on anyway? Because on::click isn't a normal browser attribute. Well, if I scroll down a ways, I actually find events being added to the document itself. So Qwik is adding what we'll call a global listener. It's looking for any of these events anywhere in the document. I can actually see that down below. It's adding a global click listener. And so anywhere I click is going to respond via Qwikloader. If I was to add, say, another event on my button, like an on blur, and I won't do anything, but let's just pretend I did. Now I see that both blur and click are globally being looked for. So then what happens when I actually do click? So our mental model of the Qwikloader, that JavaScript code that's always there the first time you run a Qwik application, is that it's adding global event listeners. So if I'm thinking about the document as a tree, as the document object model is structured, I'm not listening for events on a particular element of the tree. Instead, we're listening globally. So if we have, say, a button that has a click event from Qwik's perspective, what Qwik calls synthetic events, because there's really just one global listening event, not really an event listening directly on the button in the browser. When I click the button, what's actually happening is the click event for the entire document is being fired. And now the Qwikloader knows it needs to do some work. If this is the first interaction you have with Qwik, it actually downloads Qwik itself. We saw that in the app2.js. But then it's going to look at what was actually clicked, the button, and then figure out which component and which function within that component should actually respond to the event. And ultimately, we'll look at the QRL and execute the correct function, the function sitting in a separate file, a separate chunk created by the optimizer. That function executes, and I get the correct functionality. Now, here's a thing to note. This is not sufficient. It doesn't actually fully work. Why? Let's just run our own code where we manually add a click listener to a button, not using Qwik at all. In my HTML, I have a button with an ID of btn, and I created a function called addClickHandler. I've put my first name here. I'm adding an event listener using the functionality provided to the JavaScript engine by the browser to do this, to add a click listener, and I'm giving it a function. And I'm just going to alert hi and then this first name variable. Then I run the function. So if I click, it works. It says, hi, Tony. That's great. How did this function, the click handler, know the value of first name? Well, it's because of the feature of closures. Remember, JavaScript continued running the code after this event listener was handled. So all this code finished. And then when I clicked the button, then this function object was executed. But it had access to the first name variable, even though this addClickHandler function was finished executing and is essentially gone, because JavaScript, when creating a function object, maintains the values that were around the function at the time it was created. In other words, if instead of creating the function, I immediately executed it, it keeps access to all of the variables that it would have had access to if it had been executed at that moment. That's called a closure, and something we've talked about a lot in my other videos. And that's great and works as expected. Even though the function object is created but not executed until later, it still has access to first name. But let's try something different. Let's say I have a file. I'll essentially do what the optimizer did. I'll put click handler in its own file and just have the alert with the reference. And then I'll change add event listener so that it adds the click, but is an async function that does a dynamic import of the JavaScript file. So the browser will go out, get this file, grab the click handler, and then execute it, but only after I click. Let's see what happens. Nothing. If I look in the console, I see that I had an error. First name is not defined. The function did not have access to the variable first name. If I was to change the function to not reference that variable, it works. But if I try to access it, I'm getting an error. The issue with dynamically importing this JavaScript, that it's imported from a module. And this approach means that the function, this click handler function, will not be set up by the JavaScript engine to have any access to these other variables via closure. So this simple example doesn't work. In order to lazy load my JavaScript functions, I need to somehow give the function what the JavaScript engine normally would have given it, the closures, the variables outside the function that it should have had access to. And we're starting to get a glimpse then of what Qwik is doing. Note that this code here is essentially equivalent. It's lazy loading this alert, the function that runs that alert. But it works and has access to the variable within the closure. Qwik is doing that by serializing the closures. That is storing the information for the closures in the HTML being delivered. For example, we already saw that Tony is here in this JSON object. And when we go up and look at the end of the onClick event, there's actually a reference to values in arrays. So Qwik is using arrays and serializing things into the HTML and this JSON to essentially do what the browser is not, storing the information that the lazy loaded functions should have access to, allowing us to write our code normally. Let's look at a slightly more complex example to see. I'll replace this with a counter. My component is using the use store feature of Qwik in order to have the component maintain state. That is information that it maintains and updates. I set a couple of random values, but something that we can easily find in the source code. Then I said, show me the value for count, and then on click, increment the count by whatever the increment variable is. Notice that for this onClick function, both count and increment are part of closures. Count on the store and increment here outside of this function, which will be lazy loaded because I've specified this $sign. Here's a few things to note. In the HTML, in a lot of JavaScript frameworks, this 987 would actually be the placeholder. And in the browser, this placeholder would have been replaced with 987. But here, the HTML was generated on the server. So what I'm actually getting in the HTML is count : and then the value of store.count. But then if I click, the value changes. The JavaScript is downloaded, and the value in the DOM is updated. In a lot of other frameworks, to do this requires something called hydration. What we mean by that is, how do you know where in all this HTML is the right point to update this value 987 to what it should now be 992? To do that, a lot of other frameworks would actually recalculate the entire tree of objects, the entire tree of elements that should be created on the browser, and then compare that to what's in the DOM, and then kind of figure out, reverse engineer the DOM to say, well, this is actually part of this component over here, and so this is the function that should be run, etc. But Qwik, again, is all about serializing the information for later use, so we can actually see the component boundary information, meaning that here's where this component starts, section, section, and here's where this component ends, section, section. Notice there's even an ID, a key of the component, and that is the same ID, that's the file name of my component. So Qwik just has to look at its own HTML to understand which pieces of the HTML were created by which component. So the click event is going to execute the lazy loaded JavaScript. And when Qwik goes to update the DOM, it knows where to do it without having to recreate all the HTML internally in order to figure out the appropriate location to make an update. It just updates in the right spot. This is all part of what Qwik calls resumability, meaning that this information was delivered from the server, this 987, but the browser, now which is taking control of the interactions, is able to continue doing the calculations and the updates and the interactivity without having to redo any of the work done on the server. Qwik didn't have to say there should be a P with a count with the colon with the 987 and another P, and then figure out where that is and compare, or any other approach like that. It instead was able to take this HTML from the server and resume the execution of the application, take an event and do the appropriate action without having to run a lot more JavaScript. So thinking again about our mental model of Qwikloader and what Qwik is doing, the event happens, which is really a global event. And one of the actions that Qwik has already done, because the information is already there, is essentially recreating the closures. That happens as part of that file that's then executed and that function that's executed. When I look at the client bundles and I look at my lazy loaded function, there's a feature of Qwik called use lexical scope, which actually pulls in increment and store. And then my code is right there. And those values, which would have been available via closure, are made available via Qwik. And those closures are available because they've been serialized into the HTML. Remember, increment is 5 and the count is 987. And if I look down in this JSON, there those two values are. But again, I didn't have to think about any of this because Qwik, with its optimizer and Qwikloader, etc., is taking care of the work to make this work in a lazy loaded way. I think this is a fascinating approach to dealing with a lot of downsides of large JavaScript frameworks and large applications, especially knowing that a lot of people out there in the world are dealing with slow internet, prepaid internet plans, slow phones with slower processors, etc. When you think about an application built with Qwik, you can think about the sequence of events of a user doing various clicks and actions within the app that might lead to new screens or new states of screens. And as I move around, JavaScript is being loaded. In actuality, in production, Qwik does a lot of prefetching, meaning it downloads the JavaScript but doesn't yet actually execute it. That's great because we're essentially utilizing that pause of the real world. I, a user, open up a screen, I don't act immediately, at least not from a computer's perspective. There's time before I move my mouse and click or tap the screen. Qwik has enough time to download some things, even sometimes based on what's visible on the page, so that it doesn't have to do the download when I click. But either way, the JavaScript that's actually being executed is based on what I'm doing in the application, and not just the pages that I'm going to, but at an interactivity level, at an event level. The things that I'm actually interacting with on the web page or web application corresponds to the JavaScript that's being executed after being lazy loaded. So no matter how big my JavaScript app is, I'm only ever downloading and executing the JavaScript that has to do with the sequence of things I'm doing in the app. And I think that is important. It's essentially a built-in performance increase. And I, the developer, really don't have to do much of anything. What do you think? I hope this mindset is the future of JavaScript frameworks. And that's it. That's under the hood of a resumable JavaScript framework. There's a lot more to Qwik, of course, which maybe we can cover in future videos. I hope you enjoyed this quick look. Sorry, couldn't help myself. If you like this video, check out the links in the description to Qwik, as well as to my Patreon on patreon.com/TonyAlicea. And on my channel here on YouTube, check out my interview with Miško Habery, creator of AngularJS, Angular, and a co-creator of Qwik, for even more details. And of course, you can subscribe to my channel for more videos. Thanks for watching, and happy coding.